Assalamualaikum and good day. We are from the group 10 of the structure analysis and we'll present about our project, the TRUSS Bridge. My name is Muhammad Lufitri bin Muhammad Roslan, CF190137. My group mate is Nurul Ilyana Shahira binti Helmi, CF190231. Nurul Faikah binti Rosipan or Abdul Razak, CF190213. And Muhammad Haziq bin Gatiman, CF190063. Okay, this project involved a group of 4 members that been tasked to design a model of truss bridge with their own creativity and analyze force and reflection of their truss bridge model.
Before going any further, let me start with the introduction first. Structural analysis is the determination of the effects of loads on physical structure and their components. In bridge, truss is composed of a series of wooden or metal triangles. Given that triangles cannot be distorted by stress, a truss gives stable form capable of supporting considerably external loads over a large span. Trusses are popular for bridge building because they use a relatively small amount of material for the amount of weight they can support. They are commonly used in covered bridge, railroad bridge, and military bridge. Before, people crossed over by stepping on the stone or swimming over, but now, with the evolution of technology, the bridge structure was improved. There are three objectives we want to achieve in this study, which is number one, to analyze the internal force developed in trusses based on external loading applied. Number two, to determine the deflection of truss bridge based on external loading applied. And the last one, to compare the analyzed data of manual and software calculation of the truss bridge design. Goal of this study: to ensure the students with us able to apply the theory knowledge, formula, and gain experience for the preparation of real-life practice. Scope of this study: the idealization of bridge structure is being innovated based on creativity and improvement of the structure. In theoretical deflection and internal force, the bridge been analyzed using joint method and unit load method. After calculation, the result of manual calculation will be compared to software result, which is Structure Analysis and Design Program or StatPro.
This is the design of our truss bridge. From here, we see that our truss bridge have 3 reactions, 26 members, and 14 joints. We use the formula of members minus 2 joints minus reaction to determine this our truss bridge. And we got that 26 minus 25 is equal to first degrees of indeterminate. When the members is greater than 2 joints minus reaction, we got that our truss bridge is statically indeterminate. And also, when the reaction is equal to 3, we got that our truss bridge is statically indeterminate. So, from here, we can conclude that for our designs of truss bridge, we got that our truss bridge is a statically indeterminate with first degree of indeterminate, which is the determinacy is also a statically internal indeterminate.
Hello, my name is Nuri Eliana Shaira. So right now I'm going to be explaining about the method of analysis we're using in this study. There are 2 types of analysis, which is software analysis, whereby in this case we're using StatPro, and manual analysis. So for the software analysis, first we need to place the nodes and beams at the beginning to create a complete truss bridge. Then we need to place a specified cross-section and material, whereby in this case we're using 0.001 meters squared of cross-section with a prismatic T-beam and the material of steel. Then we need to place dead load, which is self-weight, and live load, which is 1.962 divided by 2, which means there are 2 points there. Finally, the truss will analyze and the result of internal force and deflections is produced, whereby it is then formed into a completed report of analysis. Then for the manual analysis. So since we're using an internal indeterminate truss, the internal force were analyzed using the method of joint by eliminating one member of redundant. Then we need to place back 1 kilonewton of redundant to find internal force, which is mu by using the virtual work method and alternative method. Next, the value of redundant R is calculated to ensure the stability of truss by identifying internal force for the redundant member using the equation of redundant. Then, the overall new internal force have been identified. And finally, we can identify the value of deflection by using the equations of deflection.
For the results and discussion that we can obtain from this study is the design of the bridge is statically indeterminate first degree with internal redundant. The member we chose as a redundant is member DK, and from member DK we calculate the deflection and we obtain negative 0.002 mm. The error that we found for manual calculation and software calculation is 3.5% for maximum value of error and 0.6% for minimum value of error. The error occur are probably because of human error in manual calculations or the precision of the actual bridge design in software or the use of decimal place.
In a nutshell, identifying the type of redundant appear in the structure is important because the number of unknown surpass the number of equilibrium equations. The advantage of using a redundant is reduced in deflection, enhancing stiffness, and more stable. In this study, we're using the length of span of 1.2 meter resulted the decision to use a prismatic T-steel beam with a cross-section of 0.001 meters squared. As proved in the context of Nepal, T-beam bridges more economic cost and it is usability up to 30 meters span. Based on the result obtained, the slightly error of manual and software calculation is found due to a little difference in decimals value or a human error and the advanced parameter of analysis in software calculation, which basically may affect some of the accuracy. However, based on the observation of the error, most of it is acceptable, and the displacement occur in this truss bridge design is proved to be in smaller value despite the thickness of cross-section and the external load applied. The maximum error of comparison between the manual and software calculation is just 3.5% for the internal force and 0% for the deflection. Therefore, the indeterminate design of truss bridge is proven to be more stable due to the additional member of redundant, even though it is somewhat expensive than determinate truss. Thank you.